Hello everyone, this is Anand Ranjan, Assistant Professor, School of Computer Application, Babu Banarsidas University, Lucknow. Welcome you all in the video lecture series of Digital Electronics. In this video, we will discuss the excess3 to BCD code converter, which is excess3 to BCD code converter. Okay, so this is the topic, and to analyze this topic, we'll have this table here, in which initially we are having these are our excess3 code, and here we have the corresponding BCD code. Okay, so means of course when you are going to write the function of b naught, okay, function of b naught. So what I am trying to say that the b naught will be a function of three variables, that is your E3, E2, E1 and E0. Okay, and that we will consider means again in the same way by which we actually analyzed previously, but keeping into consideration that now we are going to write the Boolean expression for B naught. So in that case, the initial means in excess3, as we know that in excess3 codes there are two ranges which are considered as the don't care, right? The first range is 0 0 0 to 0 0 1 0. Yes, because you can see here our first code is starting with the 3, because 0 plus 3, that's why we are writing over it. Or in decimal equivalent we can say, am I audible? Yeah.
Yes,
Hello.
sir.
Hello.
Yes, sir. Yes, sir.
So what I can say that our first don't care condition is 0 to 2, and another don't care condition will start with this is 1 1 0 1 2 1 1 1 1. That is means from what you can say, it's a this is equivalent to 13, yeah, to 15. Okay.
mgmt command है.
Hello. Hello.
Yes, sir.
Yes, sir.
So the concept is clear. Yes. So what you can write here, the b naught will be a function of course, this e naught, e2, e1, e0, and also you will consider the don't care conditions. Those will be your 0, 2, 13, 14, and 15. All right. Okay, and similarly you can also write that your remaining all means b1 and b2 and b3, these all are also the same, means function of 4 variables starting from e0 to e3 along with these don't care conditions. Okay, and more specifically you can also write in terms of min-term representation that your b naught will be the function of m along with what you can write, your first one is corresponding to what? Hello, 4 or not? Yes, if you write the decimal equivalent of this extended BCD number given over here, then this is what? 4, na? Hello. Hello,
Yes, sir.
am I audible?
Yes, sir.
Yes, sir.
Okay. So this is B naught will be a function of 4. Then another one I am getting over here, and this is corresponding to 6. Yes. Then we have another one over here which is corresponding to 8. Then this one is corresponding to 10, and this is corresponding to 12. And plus you can also consider the don't care condition, which is 0, 2, 13, 14, and 50. Okay, so this is the unsimplified boolean expression you write over here with respect to b naught. And similarly you can also write b1 expression, which is equal to sigma m, and this time that one is corresponding to 5 and 6. This is 5 and 6. Then this is 9 and 10. 9 and 10. Okay, 4 ones are there in this column b1, so those are corresponding to these min term 5, 6, 9, 10, and plus this don't care condition. Similarly you can also write for b2, which is having min term starting with, this is, let's say, 7, 8, 9, and 10. Okay, and plus the don't care conditions, and this b3 can be written as sigma m, and only two minterms are there, which is correspond to your 11 and 12. Okay, this is 11 and this is 12, and plus don't care conditions. So what you can say that of
Hello,
course
sir.
these hello, hello, yes, hello,
सर
सर
पढ़ाई
अनुज
hello,
बोल रहा अनुज बोल रहा है सर अनुज
yes Anuj, tell me,
अटेंडेंस लगाने के लिए बोल रहा है सर
Oh, sir.
do you want to say something? Okay, all right, so these
उसका
we
नेट
not
खत्म हो
really,
गया सर, स्लो चल रहा है इसलिए नहीं कुछ बोल पा रहा है.
okay, so you can text me or you can write in your chat box also, no issue. So these are the unsimplified Boolean expression for the excess3 to BCD code converter. Of course, we can also implement our these Boolean expression with a given min terms by basic logic gate. But the problem is that if we do that, then of course a big size implementation diagram or the logic diagram will be there, and that is not economical, or sometimes it becomes very complex to do that. So what we are going to do, we are taking the help of K-map to simplify these unsimplified expressions. So we'll have the simplified expression. I'm writing Boolean expression in short, Boolean expression in short with B. And of course, then you will implement it using basic logic gate. So let's start. Means of course, as we have discussed here, means that B naught, B1, and B2, B3, these all are the function of 4 variables. So in that case, to simplify it using the Karnaugh map, we have to require a 16 cell K map or the 4 variable K map, and it's more specifically the 4 variable min term K map we are going to use to get it the simplified Boolean expression corresponding to B1, B naught, B2, B, and B3. Okay, so Let's draw one map, minter map. So our input variables are, this is E0, E1, E2 and E3, and we can also write the possible combination with these two E0 and E1, which are 0 0, 0 1, 1 1, 1 0, and similarly here 0 0, 0 1, 1 1 and 1 0. We can also write because we are using the midterm approach, so we can also write it like this. This is E1 bar, E0 bar, E1 bar, E0, E1, E0, E1, E0 bar. This is corresponding to E3 bar, E2 bar. This is E3 bar, E2. This is E3, E2, and this is your E3, E2 bar. At the corner, you can write the decimal equivalent of each minterms which is associated with each block of this 16 cell K map. For example, this will be all four zeros, so it will be written as 0, 1, 2, 3, 4, 5, 6, 7. This is 8, 9, 10, 11, 12, 13, 14 and 15. And this we also can have one important thing which we have to also taken into consideration, that this time the don't care conditions are here, means 0 to 2 are the don't care conditions. Similarly, the 13 to 15s are don't care conditions. So let's mark those don't care conditions also inside this map. So these don't care conditions are 0, 1 and 2, 13, 14 and 15. Okay, and the same map we are going to use for the simplification of all unsimplified Boolean expression, which we have seen in the previous slide, right? So let's take a copy of this. Am I audible? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
And
क्या चिरान क्या हाल चाल तेरा बर्थडे है
another two copy for
हैप्पी बर्थडे चिरान एंड उर्फ सोएब क्योंकि असली नाम तेरा चिरान ही है ठीक है क्योंकि तू चिरान बहुत कहलाता है सीधी सी बात है ठीक है मैं दो तीन चीज बोलूंगा
so what we can say that if for example we are considering this
हम सबको रहो
first, this is for,
ठीक है इसलिए थोड़ा सा थोड़ी सी मेहनत कर ले जाके
let's say this is for B naught.
Hello, sir.
तो फिर कोई दिक्कत की बात
Yes, this is for B1.
हाँ सोसाइटी में रह लेना
This
Hello.
is
जतन ने बोला था कुछ बोलने
for B2, and this is for
आवाज आ रही?
B3. हाँ बोलो.
Hello.
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 सर उसका नेटवर्क इशू कहना चाह रहा है कि अटेंडेंस लगा लीजिएगा।
अटेंडेंस के लिए मत आया करो मेरी क्लास में भाई, मैंने मना तो किया है, क्या जरूरत है? मैं पहले ही कह चुका हूँ, जिसको नहीं करना मत करो भाई। मुझे
नहीं
अपनी
सर,
अटेंडेंस व्हाट्सएप कर दो, कंसीडर कर दो।
नेटवर्क इशू सर उसको शायद।
वीक हो रही।
अभी क्लास शुरू नहीं हुई, तुम्हें अटेंडेंस ही पड़ी हुई है। अनुज, मैं तुम्हें अपनी क्लास से रिमूव कर दूंगा परमानेंटली। Okay, shall we start?
Yes, sir.
Yes, sir.
So my board is visual, yes?
Yes, sir.
यस सर।
Okay. So let's take these unsimplified Boolean expression also copy to the next slide so that it will make us made easy for us to map all the min terms corresponding to this. This is Control C command, and here I'm going to paste it. Okay, so this makes us a little bit helpful for mapping all the min terms corresponding to the min-term maps for V0, V1, V2, and V3. Okay, so now tell me this for simplification of V0 and simplified expression, I am going to map it in the V0 K map, and so that I'm writing 1 here and then 6 here, and this is 8, huh?
Yes, sir.
4, 6, 8,
10,
and then
12.
and 12 and 12. Okay. All right. So now you tell me what the biggest size adjacent cell group you can observe in there.
7 octal.
Yes, one of it, and of course because we have we know that these 4 cells, okay, these 4 cells, are adjacent cell corresponding to this, so that we can make a group of 8 adjacent cell, which is an octet. And when solve this octet, then what we will get? Tell me, B naught expression will
E naught bar. E naught bar.
yes, because nothing will get common row wise, so only column wise what you can get common among these 0, 0 and 1, 0 means 0 is common, so 0 is corresponding to E naught bar. So you can write here, this is E naught bar. Okay,
Yes, sir.
it is clear?
Yes, sir.
Yes. Okay. So now let's similarly we solve for B1. Okay. So I'm gonna map B1, and in this case I'm going to write this 5. This is 6, 5, 6, 9, and 10. Okay. So now tell me, in this map, what is the biggest size group you can observe?
सर फोर की ग्रुपिंग बन रही है।
एक क्वाड बन रहा है,
These
सर।
are 2 quads.
2 क्वाड बन रहा है।
What do quad? Yes, excellent. Though there are 2 possible quad you can observe here, out of which one is this, and when you solve it, then this will give you a term, which is
E1 bar,
E1 E naught, and another quad is this, and when you solve it, you will get another term, which is E1
E1 E naught.
bar, and when you combine these two terms, it will give you a simplified Boolean expression for E1, that is
E1 XOR E naught.
Even XOR E naught.
E1 is equal to E1 bar E naught plus E1 E naught bar, and which is a standard expression, means we can write it as E1 XOR with E naught. All right.
Yes, sir.
Hello.
Yes, sir.
Yes. And now let's move on to the B2 simplification for the B2. And to do that, I'm going to mark first the min terms associated with B2, which are 7, 8. means here is 7. This is 7 and 8, 7, 8, 9 and 10. This is 9 and this is 10. Okay. Now tell me what is possible grouping you can observe here. Hello.
One quad, sir.
Yes, sir.
One quad. Yes, this is one quad is possible quad. Okay.
Sir, second quad also. Sir, corner quad
And
से quad बन जाएगी.
if you solve it, then you will get
E3.
the term which is can be written as row wise. What is column? E2 bar. So this is E2 bar, and column wise what is common? E1 bar.
E1 bar.
Yes.
Yes, sir.
E1 bar, and another possible
one more quad.
grouping
0, 2, 8 and 10.
like this pair is you can make a group. Yes.
Yes, sir.
Hello.
Yes, sir.
Yes.
Yes, sir.
And if you solve this pair, then you will get one term which is row wise. What is column? E2,
E2.
E2,
Sir, E2,
and
E1, E0.
E1 and E0 bar. And
10, 14.
yes, one more pair is there. One more
14
pair,
दस
One
हो
more
गया.
quad.
10.
0, 2 and 8 and 10.
one pair. This pair can also form, right?
Yes, sir. E3.
This pair can also form. So this will give you the term.
E3.
This will give you the term E3,
E1, E0 bar.
E3, E1, E0 bar. Okay.
Yes, sir.
And now you can combine all these three terms, which will give you the simplified Boolean expression for B2. And the B2 can be written as E2 bar E1 bar plus E2 sorry, this is E2 E1 E0 and plus E2 E1 E0 bar. Okay. All right.
Yes, sir.
It is clear.
Yes, sir.
Yes. Okay. And now let's take the final round for B3.
11, 12.
And for B3, let me map only two main terms, 11 and 12 in this map. So here 11 and here it is 12. Okay. So now tell me, what is the possible?
One quad, one pair.
One
One
quad.
quad, one pair.
Yeah, one quad and one pair. And one quad is corresponding to this horizontal pole adjacent cell, which will give you a term. Tell me, this is
E3, E2.
E3 and E2, E3 and E2, and one pair, this pair. When you solve this pair, then you will get a term E3,
E3, E0.
E3, E1, E0.
E1 and E.
even.
सर ये जो हमारा
So-
फर्स्ट वाला बी नॉट वाला है, यहाँ पे हम 12, 13, 15 और 14 का एक कॉर्ड बना सकते हैं.
कहाँ पर?
12, 13, 15 और 14 ये वाली लाइन.
किसमें?
बी नॉट.
बी नॉट वाला.
B0 में?
यस सर.
B0 में किसमें? 12?
13, 15 और 14.
No. We have already considered this 12 and 14 already in the octet, na? So that will be considered as a redundant group.
सर यही चीज थर्ड में भी हो रही, थर्ड में कर सकते हैं हम लोग.
Third means B2.
सर 0, 2, 8 and 12.
0, 2,
2,
नहीं वो
8 and 10. सर कॉर्नर से मेरे लोडिंग से कोड बन सकती है.
no, because that will be considered as the prime implicant, and the prime implicant when we are on the prime implicant concept, then you will find that why we are not considering. I'll discuss when we have time because that is not in syllabus. But yes, we try to avoid the prime implicants, making a group of prime implicants, and that's why we cannot consider this four corners as a means as a pair of four adjacent cell or form a quad, because these are already made pair with the other cells. Okay, that's why we are making
Okay, sir.
one. So now let me write the expression for b means b3, which is equal to e3 e2 plus e3 e1 and e0. Okay,
Yes, sir.
all right.
Yes, sir.
Yes, sir.
And finally, just a simple matter of making the implementation diagram with the help of these simplified Boolean expressions, which you get after get it simplified through the K-map. So I'm gonna add a new page, and let's take whether we can take something common which is make our life comfortable for designing. So I'm going to take this thing. No, 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 no. Can I take common thing? Map, and once you get it, implement in this same way, which we are going to do here in this case of excess3 to BCA code converter. Okay, so now hello, am I audible?
Yes, sir.
Yes, sir.
Okay. So at this time, my inputs are actually this is E0, E1, E2, and E3, and of course, once these variables, input variables, you can say these are the input variables pass through the NOT gate, then of course you will get a complement values of the corresponding input variable. Okay, so our first B0 expression, when we implement to get it converted in this, so first B0 is equal to E0 bar. Okay, E0 is equal to E0 bar. This is the E0 bar row. Very simple, directly write it this fashion. This is corresponding to the B0. B0 is equal to E0 bar. Yeah, and then the second expression is E1 XOR V0. So you require to draw one XOR gate here. In which the input will be E1 and E0. Yes.
Yes, sir.
Hello.
Yes, sir.
So that you will get B1 now. All right, so the next expression is this. Yes, let me copy so that it will make us little bit help to implement it. It's not again copied properly, but yes, it's a three product term Boolean expression. To implement all the corresponding three product term, we require three AND gate, out of which one is consist of two inputs and the remaining two will be of three inputs. Okay, so let's draw first the AND gate. This is AND gate, an AND gate. This is another AND gate. And that's one more copy of this, like it. And okay, so B3 required two more AND gates. So let's make copy of these two more wait in advance for implementation of B3. And you also require two OR gate, because two level and OR logic you are going to use to implement this SOPR expression which you get. So let's draw a three input OR gate like this. Similarly, two input OR gate for D3. Let's do the connections. So in the first product term correspond to this is E2 bar, E1 bar.
Yes,
Yes.
yes sir.
Hello.
Yes sir, E2 bar, E1 bar.
E1 bar, E2 bar. This is E2 bar, and this is E1 bar. So you will get your first product term over here, and the second product term is
E2, E1, E naught.
E2, E1, E0. So this is E2, this is E1, and this is E0. Yes.
Yes sir.
So the second product term is available here at the output of this AND gate, and then the third term is E2, E3, E1,
E3,
and
E1,
E0
E
bar.
naught.
So this is E3, this is go E1, E1, and E0 bar. So this is available here, so we can connect it, and at the output of this end you will get your third product. And finally, you will have to connect all the output of these AND gate to the next level OR gate to implement your two level AND OR logic for the simplified Boolean expressions. Here you will get B2. Okay.
Yes sir.
Okay. Now tell me, what about the B3?
E3, E2.
E2.
E3, E2. So this is E3, and this is E2. So the first product term available here, and the second
E3,
term is
E3, E1, E naught.
E3. This is E3, E1. Yeah,
Yes sir.
E1, na?
Yes sir.
E1 and E0 and P0. Okay, so this term is available here. And now it's simple, you have to pass it inside this OR gate like this. You will have here the B3. So these all are corresponding to your BCD code. All right. So, for example, if when we are going to implement these code convert in our software, then you have to consider remember one very important aspect, that the position of these output variables is very much important. Okay, if you put B0 here and B3 here and you write it in a misplaced positions, then you will get an incorrect code. Okay, so those positions are very much of importance, which you have to consider when you are going to implement it in your in your digital work software. Okay, so let me write, this is the BCD code. Okay, this is your BCD code or output variables. You will have these are the outputs. Okay, and in outputs you have to read it in which fashion? You have to read it in this fashion. This is B0, B1, B2 and B3. See, when we connect the LEDs, okay, when we connect the LEDs at this output, then you have to read it in this fashion. This will be the group of 4-bit, which will start with the least significant bit B0 and MSB with the B3. Okay, then you have to consider, means for example, if one bulb is glow here, then it will be 1 and 1 is not. If over the B0, for example, a bulb glows, then you will write 1. If it is not glow, you will write 0, and if it is not glow, you will write 0, and if it is glow, then you will write 1. Then you have to completely read this corresponding to the input variable which you will provide by providing the switching input methods. Okay, so this is very important. Means this B0 is actually the LSB, and this is the MSB for your given input code. Okay, all right.
Yes, sir.
So this is clear.
Yes, sir.